So our next session is called Digital Systems and Energy Efficiency, Contradiction or Matter of Course. Our speaker is Dr. Philipp Herzig, Head of Intelligence Enterprise and Cross-Architecture at SAP.
Hi, and good morning also from my side. So this is Philipp speaking. I just want to start with a very little anecdote that is a nice segue into the story. It was 10 years ago. Remember 2012, not sure where you were. But in 2012, my mother called me. She almost never calls me, you need to know. So I knew already that I'm in trouble. And I picked up the phone and said, hey, Mom, how's it going? Right, what's up? And so on. And she said, just, son, in very serious tone, we need to speak. Because I just reviewed the energy bill of my household over the last 3 years. I was not living there anymore, but she just reviewed it. And she figured out that half of the electricity bill was caused by my HP ProLiant home server that I used during my entire computer science studies. For doing experiments, hosting a few websites for my friends and further things. And was consuming up to, overall she consumed like 6,000 kilowatt hours per year, and half of it was accounted for my little server. So she just said, hey, can you come decommission that thing, do whatever you gotta like with it, and I moved some pages into the web and so on and so forth, right, and eventually decommissioned it. So that is the segue into, that was the first time actually when I realized that computers, if they run the entire day and so on, in particular in data centers and others, consume quite a lot of energy. At the same time, digital systems help us a lot to also cope with sustainability changes all around the world. And as SAP, we take on this challenge specifically as part of the climate action, which belongs to these 17 development goals or sustainability goals of the United Nations that we tackle on. And as part of my team, we look at consistently all the applications of SAP on how we can improve their sustainability posture. And I would like to share with you some thoughts on how you may also improve your software going forward in this talk. So I talked already about this kind of dichotomy, right? If you look at this overall. On one side, digital systems boost carbon emissions. Most prevalent to all of us is what? Bitcoin, for example, right? Huge energy sucker. We notice, right? That the creation of Bitcoin takes a lot of energy. If we take about video streaming, for example, that causes a lot of I/O on the networks, traffic, right? In the entire TCP/IP system all around the world, for example, right? With YouTube, Netflix, and others. And for sure, also data centers. Take the data centers just of Germany. How much would you approximate was the energy consumption of just the data centers in Germany? Not around the world, just Germany. We don't know them precisely, but we estimate them roundabout for 15 terawatt hours per year. Now, what is 15 terawatt hours, right? Nobody really knows. Berlin, in 2020, approximately consumed 12.8 terawatt hours per year. So all the data centers per year in Germany alone consume around the electricity of Berlin as the entire city. Entire Germany consumes around about 550 terawatt hours per year. So we talk about a contribution of just data centers only, not the home computers and your iPhones and other electronic devices, to account for 3-4%. And the share, at least, will also increase as digitalization accelerates going forward. So we need to talk about how we deal with this. At the same time, there's a Bitkom study now going to the other side of the house. There's on the other side a study by Bitkom. It was also a little bit criticized because people say, oh, there's a little bit of wishful thinking incorporated. I just said, we can save up, again, just in Germany, by digital systems, up to a triple million digit number of tons of carbon dioxide emissions through the benefits of digital systems that they bring us. And I would just give you a very precise example from SAP's integrated report on sustainability that we report year over year. What can you see in here? So you can see how COVID struck, right? So despite many other things, the largest contributor in 2020, 2021 was actually that a lot of business travel just came to essentially to a halt, despite many other optimizations for sure we also did with respect to our data centers, our software, amongst others for sure. But that was the largest contributor here. Why was this possible? Because we could continue our business operations, right, and had still great financial results as well, because we could continue thanks to video conferencing software, other collaboration tools you may use in order to continue working with your colleagues, with managers, whoever. So that is actually a precise example on how digital, what the benefits are to really reduce it, because it's quite significant, this drop, and we actually pulled our goal forward. So originally we wanted to become a net carbon emission zero in 2025. We pulled it forward to become this actually already next year, because we see further decline already, so that's actually a good benefit. Yeah? And we are now changing also with working models, how people come to our offices, with flexible working models, what we learned during the pandemic to actually help reducing this further. And for sure, SAP provides and works on many other cool software products that help customers around the world to also reduce their carbon emissions. One example, a very famous one, is transportation management. Right? Transportation management is used by logistics companies all around the world in order to optimize the routes, the delivery routes amongst the storage locations, for example, or delivery to the end customer, to stores, whatsoever, because you can, on the one hand side, optimize the truck and what's loaded on the truck in conjunction with an optimized route to avoid waste and to really drive the optimal route, for example, to avoid carbon emission on the street. We also work, and that's on the way in here, I looked at a report sent to me by a colleague from IBM. They did a CEO study. A CEO study, they do it for 20 years already, where they study what's top of your mind from a business challenge perspective. And it was the first year that all those global CEOs reported sustainability is the highest priority for them in their business today. But what they lack is transparency. Where is actually the majority of the carbon emissions, for example, or maybe also other things like water, electricity, whatsoever? How much is consumed where? Where are actually my levers to optimize further? This is why SAP invests into a product called Carbon Footprint Management, which according to Greenhouse Gas Protocol Scope 1 up to 3 can actually provide the necessary transparency, not only in your own enterprise, but actually across enterprises, because with Scope 3 you need to look at the entire value chain end to end, not only at your direct suppliers, but also the suppliers of the suppliers, right? From raw material to the finished good in the production, in the production to the end consumer. And this is something where we see a really great customer feedback, because it's the first time they really, through this, gain this insight they need in order to really determine, okay, where can I optimize my business, not only in financial terms, but also with respect to the green line. But this is not so much the topic, right? This is, on the one side, is the topic, well, we have digital systems. Yeah? We are all here because we love digital systems, and we know what the benefits of those are. Nevertheless, they consume energy. So what do we do about it? And the answer in this lies actually in your computer science studies. Who studied computer science in here? Or at least something related to computer science? Remember your old algorithms and complexity lecture. There you learned essentially everything. Give you one example. What is the energy consumption of one CPU second? Right? Your CPU calculating a sum for 1 second. It's 10 watt seconds, or round about 1 milliwatt hour, so to speak. That's not much. Right? That's not much. But let's take a standard SAP transaction, and just let's assume in this, right? I want to focus you a little bit on this right-hand side, paper back on the envelope calculation. Let's say you can reduce a standard business transaction like goods receipts in an SAP system, for example, which is in a storage location issued maybe 100,000 times per day, multiple million times per year. We can maybe optimize this by 1 CPU second by using a better algorithm, for example. Yeah, or using a better library. For some of the geeks in here, if you just take Python and you sum up all the numbers from 1 to 1 million, right, just with a naive for loop versus you take NumPy, you can save an order of magnitude of energy consumption with your algorithm, for example. So it's easy, usually, to optimize your algorithms, right, to consume less energy here. And now let's assume further this transaction is heavily used around the globe by 1.5 million users, multiple times per day, 230 times per year. That's already an energy saving of 90 megawatt hours that we can have in this year. And now let's assume we can do all the transaction, maybe with 500 developers, and every developer optimizes 10 transactions just by one CPU second, or to save these 10 watt seconds. You can save up to almost 100K megawatt hours, which is the entire energy consumption of a small city with a population maybe of 50,000 people living in there, just by optimizing the algorithms by one CPU second. And now the interesting thing is even further. If you now say, okay, what can I do this, not just to pick the right algorithm, what do you know, how much for the same 10 watt seconds, how much would you assume can you store data in memory? So what is the equivalent, right? There's CPU, there's memory, right? And a computer usually consists of 4 things, right? A disk, network, I/O, a CPU, and some memory. So for the same 10 watt seconds, you can store 10 gigabytes of data in memory. 10 gigabytes. In computer science lessons you learned back then, you should use caching, for example, right? So if you have a complex algorithm in machine learning, for example, and you need to recompute the same thing multiple times, just store it in memory. It not only makes your algorithm more performant and much faster, but it will be also much more energy efficient going forward. And this is the direct relation when I talk to my developers and they are lazy about optimizing the code, right? Because many developers today come out of university and say like, hey, I'm the only developer in the world, and this is this massive computer that lies in front of me, and I can prang in every code I want, right, that I learned after 1 week. And then, they are not picking up the best algorithms necessarily, right? Because there's pressure on features, there's pressure on thousands of other things, security and so on, but they are not necessarily picking up the fastest or the best algorithm to do actually the job. But they can, because then I tell them, look, it's not only that the software is more performant, contributes to better user experience, and because we love fast responding systems, but it also contributes to a more sustainable world. This is my call to action also out of this. So if you touching developers, or if you are a developer and so on, take this seriously. It's an emerging field to think about this, how we can further optimize this. It's basically a new field that started like 4 or 5 years ago, but it builds on the entire history of computer science in the last 50 years. And here's some trade-offs, right? We believe always putting stuff to memory because we can put lots of stuff into memory by reducing the energy consumption, because disk from an energy consumption is always more expensive than memory. CPU is always more expensive than putting stuff into a cache, for example. Network is always, real I/O over the network is always more expensive from an energy consumption perspective than using, for example, a network cache, caching something in the browser, in the UI, and not calling the backend all the time, for example. That contributes to the overall goal. And another contribution for sure is not only the code, right? This is what we can directly influence as developers. We can directly as developers influence how we write our code, right? And the better we write them, the more efficient libraries we use, the more efficient algorithms, the better. But what we also see is a tremendous leap forward in hardware in terms of what we actually can get in terms of compute power versus the energy consumption. So what you here basically see is the green 500 benchmark, running really the hardware at full load, at 100%. And you see that we actually have improved our power efficiency in modern CPUs by an order of magnitude alone in the last 7 years. So we can compute much, much more with the same, 10 times more with the same energy consumption, so to speak. And many of the benefits we see in consumer products like Apple MacBooks recently with the M1 chip, with the M2 chip, with other ARM chips, et cetera, that heavily contribute to this as well. However, the problem with this is, And this is also the segue then why the cloud, for example, is so important. Usually this is nice, right, that the hardware is getting better, but usually you never fully utilize the hardware. You never fully utilize the hardware. So usually you find the workload of a typical SAP system, and this is a standard benchmark we use to certify hardware inside SAP, like new HP hardware, new IBM hardware, for example, using a benchmark from retail that is representative for usual retail customers where you may purchase your groceries from. And what you see here is, you see two extremes, right? You saw the one from the slide before, where you see at high energy consumption, well, then also the relative power consumption is the highest, right? 100% workload on the system corresponds to 100% energy consumption. But also if the system is idling, it's not like that we are scaling to zero, right? So there's always kind of a fixed cost or a fixed energy consumption, even if the system doesn't do anything. And then there's for sure a curve that you see, and it's interesting that up to around about 50 to 60%, depends a bit on the workload, depends a little bit on the hardware, you can actually see that the relative energy consumption still the power consumption increases, while at the same time the relative throughput, what we really get through the system, is optimal. But this curve changes its nature, the more we try to get throughput through the system, which is natural. The usual effect in your life would be the more work you take on, the more accidents happen, right? The more you need to spend on replanning and mitigating problems and challenges and so on, right? Which also sucks up your energy, but you're actually not getting nothing of the real work done, right? This is the same, right? From this perspective, computers work the same like human beings. So this is an interesting effect because it is important why the cloud in particular becomes so relevant, because in the cloud, we can do the resource sharing. In the cloud, resource sharing happens that you can avoid, for example, idle times because somebody else may issue workload on that specific system. And what we offer also here, and just to conclude then also already this little short talk, is provide out of SAP a couple of offerings to manage this actually. So with the landscape management tooling, just to give you an example, we can precisely say for an SAP landscape, which are usually complex, right? If you go to larger customers and companies, for example, in Germany, we can predict and also recommend to say, hey, in this part of your infrastructure, in your landscape, there's an optimization potential. So here, for example, you have a lot of virtual machines up and running, but during the weekend, for example, nobody is using them. So you may want to initiate a plan to shut them down, and then we can predict very precisely how much energy can be actually saved, for example. We also have another product that is more for the cloud that is called Gardener, that is used to automatically manage Kubernetes clusters. And in SAP, we manage tens and hundreds of thousands of Kubernetes clusters. And based on this sheer scale, what we can do, or what we see, is we see patterns that, for example, also again over the weekend, on where there's a day off in a certain region, we have implemented features like cluster hibernation. So we can shut down automatically entire clusters in certain regions where the compute power or the memory power may not be necessary. And we made this available also as open source as another contribution to the ecosystem in here. So to just wrap it up, overall, there is no contradiction, right? It doesn't go without digital systems, right? But at the same time, digital systems contribute to carbon emissions, but we can optimize them. But it's our responsibility to actually do this. And with this, I'd like to thank you. I hope you can take away a few insights that are useful also with your companies, to ask maybe some questions around the right insights on sustainability in your companies. And with this, happy to receive questions, either here if we have time or outside. But thank you very much for coming by and listening in.